Good evening, my dear student. Welcome into my new session of induction motor. Before I proceeding, I like to recall the previous lecture which I have discussed with you regarding the principle and operation of induction motor, construction working principle, equivalent circuit, power losses diagram, and torque speed curve and equations also. In this session, we will doing some numerical practice. So, my dear friends, we will take a one important numerical on the power loss. Numerical on power relations. So, firstly, we read the numerical. A 480 volt, 60 hertz, 50 HP three-phase induction motor is drawing 60 ampere at 0.85 power factor lagging. My dear student, before I'm solving this numerical, I like to call each and everyone has to take the pen and pencil with a notebook and write it down my instructions. As far as the numerical is concerned, it has given the some values of voltage, frequency, and the motor rating in HP. It's a horsepower. When we are going to convert it into the watt or kilowatt, we can. And also the current rating is given. The stator copper loss, we have already studied about the stator copper that is PSCL, that is 2 kilowatt, and rotor copper losses is given 700 watt. Friction windage losses are 600 watt. Copper losses are 1800 watt, and stray losses are negligible. Find the following quantity, and the quantities are the air gap power. Air gap power already I have discussed with you. When we are drawing the air gap power, it is a power that is P input minus P stator copper losses minus P core losses. I'm talking about when here we can see how we can find out the PAG. This is a formula. P in PSCL calls a P stator copper losses and P core losses. Now, what is the formula of P input? Already I have discussed you root 3 VL IL cos theta. VL is given, current is given, cos theta is given. There is a power factor is given. So we can find out the power in kilowatt or the watt. Why I says I just find out in kilowatt? Because all the losses in kilowatt given in the circuit. So total PAG we can find out 38.6 kilowatt. Similarly, when we are going to find out the converted power, the formula is P converted equal to PAG minus PRCL. PAG we have find out over here. RCL is 700 upon 1000. Why we are doing this? Because the rotor copper loss is given in the watt. So we divided by the 1000. We got the value of 37.9 kilowatt. Now here, this is the output power. Output power is given by this equation, that is a converted power minus friction windage power. So similarly here we can find out the output power. Now he questioned about the efficiency of motor. Motor efficiency motor, we know that the efficiency is a ratio of the output power to the input power. When we are going to find out this, the efficiency is 88% of induction motor. So this is all about the simple numerical of induction motor. Now we will discuss about the torque slip speed or speed characteristics. My dear students, it's a very important characteristics. In every exam, number of the questions may asked in this topic. So I like to call your attention on this particular topic. Before I proceeding, the torque slip characteristics, the question is coming into mind. That is, what is the need to draw it, and what is torque, what is slip. Already I have discussed. And what will be the effect of torque when slip is goes up or goes down. So we have to understand the nature of induction motor. We have to draw this particular characteristic. So what I have done in this characteristic, I have taken one total characteristic of slip as well as the speed. As you have seen, this is my characteristic I have drawn in this figure. There are three sections. One is braking reasons, motoring reasons, and generating reasons. But when I'm talking about the torque slip characteristic, so we have to focus about these reasons only. This is a reason. This is the reason. Only the motoring reasons. When we're talking about torque slip characteristic. As you have seen, the slip direction of the slip is backward, right? So my characteristic can be seen from ns to n0, right? Got this point. Here at this point, ns, the rotary speed is equal to the ns. The slip will be 0 over here. Here slip will be 0. Okay. Now I have divided my characteristic into the three reasons. One is low slip. The low slip value can be 0. Second is medium slip, and third is high slip reasons. In each and every reason, we can discuss about the slip characteristics. So in the low slip reason, when the value of s equal to 0, when the value of s equals to 0, then by this formula torque will be 0. Got it? Here the torque will be 0. So we start from this point. This is a point we'll have to start it. Now come to the medium slip reason. In the medium slip reason, the value of slip is small. So term sx2 square will be negligible or small. When it is small or negligible, the total value can be calculated by this formula, that is S upon R2. Here the torque is proportional to the S. Now my graph will be going straight. It linearly increases. So I called it stable region. When it reached to the maximum point where I got the maximum torque, here the slip is maximum. Now again, now third reason is high slip regions, because now the slip value will in this category come, right? Here for the last value of slip value is approaching to 1, and I2 square, R2 square will be negligible. So my torque will be TR inversely proportional to 1 upon S. That is why my slip is exponentially goes down. And this region is called the unstable regions, right? When this point, when my slip comes to this point, it has the TS called the starting torque. So this TS will be taking here as a reference, right? So this is starting torque, this is my stable region, this is my unstable region, I can say. I hope you understand, my dear friends. Now come to the torque speed characteristic. When I'm talking about the torque speed characteristic, I've divided my characteristics in three regions. One is motoring regions, braking regions, and generating regions. At motoring region, the slip will be positive. In generating regions, the slip will be negative, and braking regions, slip will be in the brake slip will be as greater than 1. So in motoring region, in this region, the value of the slip lies between the 0 to 1. So slip is positive. The motor rotates in same direction as that of rotating magnetic field. In this region here, the motor rotates in the same direction of rotating magnetic field. In this region, the slip will be 0, so, and the torque produced by the motor is 0. Hence the induced voltage rotor is 0, and the condition will be N equal to Ns. The torque is increases as slip increase, while the air gap flux remain constant. Point to be noted. When the torque is increases, slip will increase, and while the air gap flux will remain constant. Now come to the second reason, that is a generating reason. In this operating mode, the slip is negative. It means slip is less than the 0. The slip will be negative if and only if the rotor speed n is greater than the synchronous speed. When the rotor speed is greater than the synchronous speed, then my slip will be negative. I can say the ns should be less than the nr. However, the rotor and RMF both rotate in the same direction. It doesn't matter. Now, and the point is, in this region, we have seen a one point. In this region, the motor acts as a generator. Now, the motor acts as a generator and return to the power back to the AC source. Now, come to the braking region. It's very simple. In the braking region, here my slip is greater than 1. It is neither positive nor negative. So I can say it is S is greater than 1. In this region, the value of slip is greater than 1 and the rotor rotates in the opposite direction of rotating magnetic field. Here the direction of rotor is opposite. Dear, focus. In the braking region, the direction of rotor is opposite to the rotating magnetic field. It is achieved by the interchanging. देखिए please, achieved by the interchanging any two phase of stator supply. We can obtain this reason by changing the two phase of stator supply. Got it? We also work used as a braking or in the plugging mode. And after it, if you are having doubt, you can write the comments in my comment box, and definitely I'm trying to solve your problem. Thank you, my dear friends.